Hello! Today we're going to talk about scientific testing. By the end of today's video, you should be able to answer the question, how do we know two groups are different or if it's just chance? The main objective of scientific testing is to find if two or more groups are significantly different from each other. Let's go over some vocabulary. Testing. Testing is just measuring something. It could be distance, height, the number of bee stings, population, or growth. And a cholesterol test measures the amount of cholesterol in your blood. Statistical analysis studies the data to find differences, patterns, or trends, if any. A placebo is just a pill or an item that does nothing, but the test participants don't know that. For example, participants might get the new brain enhancer pill, but it's just flour and sugar. Other examples of a placebo would be a magic feather, which is just a normal feather, or a liquid luck potion that is just water in a fancy bottle, or pro skater shoes, which are just Vans. The placebo effect is the difference in test results caused by a person's belief that the placebo works. An example of the placebo effect would be someone who takes the new brain enhancer pills, just flour and sugar, and actually doing better on a test because they felt smarter. Another example is when Dumbledore's magic feather allowed him to fly, or when Ron Weasley thought he drank a magical potion and scored more points in Quidditch. However, the placebo effect has limits. If you didn't know how to skateboard, confidence in your pro shoes isn't going to let you rail. Accurate means correct. Precise means consistent measurements with only the smallest differences. The difference between accurate and precise is best shown visually. So when I say go, quickly take 4 imaginary shots at the target on your screen. Ready, set, go. Pew 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 pew. Well, you were not accurate, but you were very precise. Let's try again. Ready, set, go. Pew 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 pew. Okay, this time you were accurate, but not precise. And if you take the average, you were pretty dead center. Let's try one more time. Ready, set, go. Pew 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 pew. What happened? This time you were not accurate and you were not precise. One last time. Ready, set, go. Pew 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 pew. And look at that, you were both accurate and precise. Let's go review a scenario to better understand the importance of proper scientific testing. So stop, listen, and think about the following scenario. A scientist is performing a test to see if hair length is connected to math ability. So the scientist goes to a high school math competition and gets 10 volunteers with long hair from the top teams and gives them an advanced math test to complete in 1 hour. Here's a high school freshman solving the problem with no issues. The scientist then goes to an elementary school and takes 10 volunteers with short hair who failed their last math quiz and gives them the same advanced math test to complete in 1 hour. Here's a third grader in a panic as they struggle to solve the problem. After grading the test, the scientist found that long hair people do better in math than short hair people with a p-value of less than 0.05. So what's wrong with this test and how would you fix it? I'll give you a second. What's wrong is the testing groups are from different populations and not equivalent to each other. Both test groups should have been taken from the same population and randomly selected to remove bias. Now let's go into the details of testing two groups. First, the groups should be as large and equal as possible. That means not only should they have the same number of people, but also that the people should be from the same population. You should have at least 10 participants or samples per group. Use random selection to remove bias. When testing two groups, there are two common testing situations, before and after, and A versus B. And before and after, the same group is tested twice, before and after the treatment. For example, measuring how fast participants run the 100-meter dash before and after going vegan for 2 months. In an A versus B, you compare a group that is using A to a group that is using B. For example, measuring the cholesterol of those taking a new drug and those taking a placebo. Once again, stop, listen, and think. In scenario 2, a PE teacher compared the first mile times of this year's students to last year's students. Here's the current mile time data for this year's students, and here's the mile time data for last year's students. Are these groups different enough? How much of this difference is likely due to chance? I'll give you a second to think about it. It's quite difficult to tell if the groups are truly different as there is a lot of overlap. That's why scientists use statistical testing. Statistical testing measures how much variability, chaos, randomness, or just plain luck accounts for the differences we see between two groups. Statistical testing is a complicated topic, but put very simply, it looks at how much overlap there is in the data. If there's too much overlap, the groups are not different. And if there's little overlap, the groups are different. Again, this is an oversimplification, but it's a simple way to think about it. Let's go over the next scenario. Scenario 3. To show that playing video games is bad for your health, scientists had 15 random college students that don't play video games take a strength test. Here are some random college students that don't play video games. The scientists then had 15 random players who played video games over 3 hours a day take the same strength test. Here are 15 random college-age video game pros. The test didn't prove the groups were different from each other, so the scientists took out data from the video game player side, specifically data from people who look like this. The modified data now showed that the groups were different, p-value less than 0.05, with the people who didn't play video games now being stronger. Were the scientists' actions correct? Why or why not? I'll give you a second. Data tampering is a big no-no in science. In science, we don't hold an opinion and look only for data that supports that opinion. We look at all the data and then form an opinion. When it comes to removing data, don't do it. I repeat, don't do it. Seriously, don't do it. The only two exceptions are when some weird event occurred that influenced the test or when the measurements recorded were incorrect. For example, let's say scientists test the running times of two senior citizen groups. However, if a kid was pretending to be a senior citizen, it would be okay to remove that data, as that's something weird and not what would normally happen. Additionally, if scientists measured incorrectly because the stopwatch was not working or the person was reading it incorrectly, then it would also be okay to remove that data. Let's talk about the different test types. There are many statistical tests. Some of the most common ones science students will use are t-test, u-test, and ANOVA. T-tests are quick and easy, but have a max of 30 per group. The Mann-Whitney U-test, or just U-test, are for when the data doesn't have a normal distribution. The distribution is skewed. On the right is normal distribution, and on the left is a skewed distribution. ANOVAs are used for large groups and can compare two or more groups at the same time. Finally, let's talk about p-values. When doing statistical tests, you will receive a p-value. In general, if the p-value is less than or equal to 0.05, the groups are considered different. Any differences that you see between the groups is probably not chains and the averages are significant, aka worth paying attention to. However, when the value is greater than 0.5, the groups are not considered different. Any difference between the groups is likely due to chance and the averages are insignificant and should be ignored. Now you should be able to answer the question, how do we know if two groups are different or if it's just chance? And that's it for now. Till next time, bye.